All right, let's go through this to make sure you understand, because these 3 sections are the last 3 of the chapter. You're going to have the review that you'll work on. We're going to go through the review tomorrow, and then the test is going to be on Thursday. So understanding these 3 sections is going to be important for you to do well on the test. So the slope of a line is always y2 minus y1 over x2 minus x1. So the slope here would be 5/2. And most everybody did okay on the first 4.
Yeah, I put the wrong one.
Next one, 3 minus 0. And 5 minus negative 6 is 5 plus 6. So that should be 3/11. Okay? To determine whether they're parallel, perpendicular, or neither, I've got to find the slopes of both lines so I can compare. So the slope of WX, 5 plus 3 is 8. Negative 1 minus 0 is negative 1. So the slope there is negative 8. And then I have 2 minus 5 is negative 3. And negative 1 minus 2 is negative 3. So the slope there is 1. There's no relationship whatsoever with either one of those slopes, so they are neither. The next one, number 4, slope of WX, 1 plus 1 is 2. 4 plus 2 is 6, so it's 1/3. YZ, negative 4 plus 4 is 0. So again, no relationship, neither.
I felt really bad about that one because I was expecting at least one like perpendicular, one parallel.
I did until I just chose it and
Okay.
I did do it. I was like, that's not right. I feel like I did something wrong.
All right, so we're trying to find the distance from P to M. We're also trying to pick the graph that shows the right line M and the right point P. So it's 3, negative 3, and 0, 0. 3, negative 3. Oh, I don't want to have this on here. Yeah, letter D can't be it because why is that? The point P is supposed to be 1, 2, and the point P here is 2, 1, right? So we can rule out D before we even start. So we have 3 choices left, and all 3 graphs are identical. So the real problem here is finding the distance, okay? And remember to use the distance formula, you need to have 2 points. We have 1 point, point P, but we don't know this point of intersection. I could take a guess, but it doesn't look like it intersects at an actual integer coordinate. Everybody see that? And we need to know what that coordinate is. Okay, so to find the coordinate would be the solution where those 2 lines equal each other. The solution where those 2 lines equal each other. So I need to find the 2 equations of the lines. Okay, they gave me the coordinates for this one, and it was what? Someone have their quiz so I don't have to go back.
3, negative 3.
3, negative 3, and 0, 0. So based on the coordinates, you can real quickly look at it and tell me the y-intercept. 0. Yeah, do you see that? When x is 0, that's the y-intercept, and you can look at the graph and see that it goes right through 0, 0. Y-intercept is 0. So now I really just need to find the slope. So I have 0 plus 3, 0 minus 3, so my slope is negative 1. So the equation of this line is y equals negative x plus 0, or just y equals negative x. Okay? The strategy here is I've got to find the equation of both those lines where they're equal to each other is that coordinate point that I need to use the distance formula with, or draw my triangle with. Okay, so now I need the equation of this line. Well, it's perpendicular slope.
Oh my god.
So if the slope is negative 1, the slope of that line is positive 1. And it looks like my y-intercept is what? 1. So the equation of this line is y equals x plus 1. Any questions on how I got these 2 equations? Because you had to do this step in order to get the problem right without guessing. Okay, you find both equations. Now, if y equals negative x and y equals x plus 1, I just set those 2 equal to each other. because where they're equal is where that coordinate is. So I do negative x equals x plus 1. So I subtract x, negative 2x equals 1. X equals negative 1/2. So the x coordinate of this point is negative 1/2. Okay? The y coordinate, if I plug in negative 1/2 for x in this equation, what's y? Positive 1/2. Negative times a negative is a positive. So the coordinate to this point is negative 1/2, positive 1/2. Now I have 2 points. I have the point P, which they gave me as 1, 2. That was given to me. And I know this coordinate now is negative 1/2, positive 1/2. Which when I look at it and ask myself, does that make sense after I do all the math? Does it look like it could be that? Yeah, it looks like it falls halfway between 0 and 1 in both directions. 0 and negative 1, 0 and 1. Okay, so now I can draw my triangle. Right? What's the distance from negative 1/2 to 1? 1.5, 3/2, right? And what's the distance from 1/2 to 2? 1/2 to up to 2. 1.5 again, right? Which is 3/2. So I have this triangle now, right? Where this is 3/2, this is 3/2. The rest I can just put in the calculator, right? We just square both legs and take the square root. Remember Pythagorean theorem? So I do 3/2 squared. And I'm just going to do it times 2 because I have 2 of them, right? And then take the square root. 2.12. Yep.
I didn't know what it felt like.
Yep. You just need, the hypotenuse of the triangle is just the distance between the 2 points. So you draw it from the intersection here to to that point, and that's the hypotenuse, and then just fill in. I could have drawn the triangle this way too. That part doesn't matter because your legs are going to be the same distance.
So you take where the
Intersection is to the point.
And then hit another point, draw the triangle, and then...
Yeah, they work out great if the point is actually an integer, but in this case it wasn't. So we had to actually solve for the point. Sometimes when you use that slope, you'll go right to another point that's right there on an integer point, and then it's really easy. This time you actually had to find what that coordinate point was before you could draw your triangle. Okay, questions on that one? This one, hopefully, everybody thought it was pretty easy. Line M contains points 3, 1, and 1, 1. 3, 1, and 1, 1. So my first, when I look at A and B, neither one of those lines contain those 2 points, do they? Nope. So it's got to be B or D.
That's A's.
I'm so stupid.
3, 1, 1, 1. So now these two are identical, and the graphs are correct. And now all I'm looking for is the distance from point P to the line. From point P to the line is 1 unit. That is it.
I'm so upset. I should have got that one right. I circled D, like the answer, on B, but then I saw D on B, so when I put D instead of B, but it was on B.
Okay, wow, hold on.
I'm so confused.
I think you circled this D down.
Yeah, I
Circled the
did, but
D
on
and the
B.
answer is B.
This one?
And so she wrote B.
Well, luckily, everybody who wants it gets a redemption quiz. So,
Oh, yes.
I'll take that redemption too.
okay.
Man, should have had Nita again.
I'm 1 point away.
So find the distance. Now we've got 2 parallel lines. The first step here is to graph the 2 lines. So it's y equals 4x plus 4. Start at 4. Use the slope. Okay, 4x plus 4, right? So there's one line. The other, I might just go ahead and, does everybody see that this is the same as that equation? I added y to one side and then subtracted 1 to get it in slope-intercept. So now, same slope, so I do confirm they are parallel lines. I'm going to use -1, and I'm going to go up 4 over 1. Up 4 over 1. Okay, we're trying to find the distance between two parallel lines. We know the distance has to be perpendicular to both lines. Okay? What I told you when we were learning this the first time, I said I like to pick a y-intercept. So I already know the y-intercept. And then I'm just going to use the slope, right, of the perpendicular line. So if I start here at my first point, the slope of the parallel lines is 4. So what's the slope of the perpendicular line going to be? -1 over 4, right? You take the inverse and the opposite sign. So I'm going to go down 1 over 4. Connect those two. I know that's perpendicular. This is the distance I'm looking for. The problem, once again, I know one point, that y-intercept, but I do not know where they intersect. If my graph was perfect, it probably still wouldn't be right there at a integer coordinate. Okay, so I have to find that point. I told you when we first learned this, there's kind of an easy way, and then there's the hard way. The easy way works when you use that inverse opposite slope, and you go down however many, and all of a sudden it hits right there on an integer coordinate point. But in this case, it doesn't. Okay, so I have to find that point before I can draw my triangle. So I'm looking at these two lines. I'm going to circle. Everybody see the intersection of those two lines in green? I circled it. Okay? So what I need to do to find that point is I've got to find the equation of one of the lines and the equation of the other and set those equal to each other. And where they're equal, that's what the x-coordinate is going to be. Okay? I'm given the equation of one of them. It's this one that goes through -1 is the y-intercept. So it's that 4x minus 1, right? So that's this one. So I already have that equation. You've already told me what the slope of the other one is. -1/4 x. The y-intercept I picked on purpose so I wouldn't have to solve for it. You see why starting at that y-intercept to find your perpendicular line is helpful here? What's the y-intercept here? 4. There are my two equations. Okay, so my step now is I set those two equal to each other because where they're equal is at that x coordinate, whatever it is. You're with me on the process so far? Okay, because it is a little more complicated than just finding that next point. You actually have to figure out the point. Okay, so what I'm going to do now is set these equal. So 4x minus 1 equals -1/4 x plus 4. Just setting them equal. Because where they're equal, that x value is going to be the x-coordinate of that intersection. Okay, what's an easy way for me to get rid of the fraction here?
Multiply everything by 4.
Multiply everything by 4. I love this trick because I don't like to deal with fractions any more than you do. Can I do them? Yes, but do I want to if I can help it? No. So I'm just going to go through and multiply everything by 4, the denominator. And the trick here is you've got to remember to multiply everything by 4. You miss 1 and you have the wrong answer. Okay? 4 times 4x minus 4 -x plus 16. Right? Now I don't have fractions, I can just solve. So I'm going to add 4 over and add x over. Sure enough, it is not an even number. But that's okay. Calculators will help me do this problem when I figure out the distance. Okay? So the x-coordinate here is 20 over 17. Just a little more than 1. Okay? Now, how can I find the y-coordinate? I know the x-coordinate. So I know both of these numbers, the x value is 20 over 17. So I can pick either one of these equations and solve for y. I'll get the same answer. I'm going to choose the one without the fraction. Okay, so I'm just going to plug in x. 4 times 20/17 minus 1. Well, 4 times 20 is 80. 1 with the denominator of 17 is that, right? -1 written as a fraction with denominator of 17. Okay, 80 minus 17, 63. So the y-coordinate is that. Now, I have my 2 points. This is going to be a really flat triangle. So I'm going to go from 0 to 20/17. Well, that distance is just 20/17. And then in the y direction, I'm going to go from 4 down to 63/17. So how many 17ths are in 4? 4 times 17, 68. So 68/17 down to 63/17 is how many? 68/17 down to 63/17. 5/17. So I know this distance is 5/17. So now I just square this, add them together, take the square root.
Well, I don't know how or what I did. I don't think I actually got that exact number, but I got something close to it. And I was like, okay, so that's the closest one.
That's specifically.
1.21,
And I did that on every single one of those.
letter C, 1.21. Okay, on the whiteboards, following the process I just did on number 7, want everybody to try their hand at number 8. I know you tried it on the quiz, but now I want you to use the process I just laid out for practice to make sure you understand what you're doing. Number 8, everyone try it using what I just did. And I can help you talk you through the steps if you want. The first thing you do is graph both equations. These are the 2 equations. Graph both equations. After you've graphed both equations, my suggestion is start with one of your y-intercepts of one of your 2 equations. Okay? And we're going to create a line perpendicular to the other by using the opposite inverse slope. So what would the opposite inverse slope be?
Negative
1/4. So start at a y-intercept and count down 1 over 4 to get a second point. And connect the y-intercept to that new point. Start the y-intercept, count down 1 over 4, and connect it. You use, that's fine. Okay, you done? 3. Okay, now you've drawn, when you connect it, you've drawn a perpendicular line to both parallel lines, right? You know one of your points is the y-intercept you picked of that line. But now you've got to find the intersection of the other 2 lines. So decide, go ahead and circle the intersection you're looking for. Okay? Pick the line, the parallel line that it's on based on what they gave you. Which line was that of the two lines they gave you? Okay, write that equation. And now write the equation of the perpendicular line. You know the slope of the perpendicular line and you know the y-intercept because you picked the y-intercept. So you should get negative 1/4 x plus whatever the y-intercept was you picked, right?
For your perpendicular line?
Yep.
-4 is mine.
Yours is -4. Someone else might have had the +4. Okay, so that's fine.
So then they
So
both-
now, set those two, drop the y's, and set the two equations equal to each other and solve for x. Yes. Yes. Okay, I used the top one. So my two equations are going to be 4x plus 4 and negative 1/4 x plus 4. If you use the bottom one, your two equations would be 4x minus 4 and negative 1/4 x minus 4. Okay, so what I'm going to do is set these two equal. Okay, and I'm going to multiply everything by 4. Is that
Oh,
right?
Sam, thanks for the support.
Plus 4.
Oh, like I did.
No.
I got a 0. You both got
I didn't set it before.
4x plus 4. I used that. Oh, this has got to be the minus 4. Sorry.
Oh, that's.
Right? Because this line here is the one I'm looking for, and that's the one that has the y-intercept of negative 4. Yep. Okay, so now I get 17x equals 32. So x is 32/17. I'm going to add x over.
What did I do?
So this coordinate is 32/17, comma something, and now I've got to find y. So I'm going to take 32/17, I'm going to plug it right in here.
Hey, that's what I got too.
4 times 32 is 128. And what is that, 68/17? 4. Right, getting a denominator of 17. 128 minus 68 is 60. So the y-coordinate is 60/17. Okay, now I can go ahead and draw my triangle. To go from 0 to 32/17 is just 32/17. To go from 4 down to 60/17 is 8/17, right? Because it's 68/17 minus 60. So now I've got my two legs of my triangle. And now I just plug it in. I take 8/17 squared. And I add 32/17.
Where'd you get 8/17?
Because this point is 4, which is the same as 68/17, 17 times 4. And this point is 60/17. So I went down from 68/17 down to 60/17, which is 8/17. Squared. And now I take the square root, and I get 1.94. Letter C.
I was so close. Choosing D instead of C. They're like right next to each other.
Okay, let's go to 9 and 10. And then we'll be done with the quiz. You're not remembering any of this, right, Isaac? Which of the following is an equation to the perpendicular bisector of GH? So negative 4, 4, and 4, 0. There's my line. So to do this problem, you need to understand what the definition of a perpendicular bisector is. And what is it?
The line that is perpendicular.
It cuts it right in half.
And what does bisect mean?
Means it goes to the side.
Yeah, so the line goes through the midpoint at a 90-degree angle. Goes through the midpoint at a 90-degree angle. Well, I'm going to not make this a line. I'm going to make this a segment because I want it to be, how do I find the midpoint of a segment? Who remembers?
Plus each other. And then
It's the average. It's the average of the x's, the average of the y's. So if I take negative 4 plus 4, what's that? 0 divided by 2 is 0. And if I take 4 plus 0 divided by 2 is 2. So this point, if I'd drawn it well, should be 0, 2. That's where the bisector is going to go through. But it's got to go through at a right angle. So I need to know the slope of this segment. 0 minus 4. 4 minus negative 4. The slope is negative 1/2. So what's the slope of the perpendicular bisector going to be? Positive 2. So I'm going to go, the slope is 2. And what's the y-intercept? If it's going to go through this point. What's the y-intercept of my line? 2. And there's the equation.
could you also solve it like you make a line and you just do
Make a line.
like you solve it like a line. So you do y equals 1/2 x, and then you do the points.
What point are you putting in?
One second. I want to see how.
Okay. Because the key here is the line perpendicular must go through the midpoint. Otherwise, it's not the perpendicular bisector. It's just a perpendicular line. So it has to go through the midpoint. Questions on that one? Okay. Last one. In the figure, find x and y. This is a repeat from a previous quiz. So the first thing you need to know to find x, these three angles add up to what? 180. So these two must add up to what? 90, because this is 90, right? So 90 minus 38. And that's the only answer that has x equals 52.
Do you remember doing that now?
I remember.
I had to do that.
Yeah, I did
First thing I
I looked at 12 and I was like,
Now, if I wanted to solve for y, what do I know about these two angles? These are parallel. This is your transversal. So these are supplementary, right? So y minus 12 plus 52, because I found x, is 180. Y plus 40 is 180. Y equals 140. Which just confirms the answer there.
I don't know how
Okay.
I got that